Assalamu alaikum. In this video we are going to discuss about medicinal chemistry of ketamine along with the synthesis. So here is a formal start. Ketamine actually belongs to anesthetic group or intravenous anesthetics, a particular general anesthetic group, which is the important drug in the intravenous anesthetics in medicinal chemistry. So if we briefly describe ketamine hydrochloride or ketamine, that it belongs to an anesthetic group, which is an NMDA receptor analog, which means that ketamine pharmacologically interact with NMDA receptor, which is an antagonist. So it blocks or it inhibits the action of the NMDA receptor. We will discuss later in the pharmacology or mechanism of action. So NMDA receptor is N-methyl D-aspartate, and it is first synthesized or discovered in 1960s, particularly in 1963. It is FDA approved item which is been approved in 1970s for clinical purposes. The structure of the ketamine, you have to memorize it. I try to make it simple and easy. So here is a graphical representation or the structure of the ketamine. The next step in the medicinal chemistry of the ketamine is the synthesis, which is an important part in any topic of the medicinal chemistry. So I will try to make it easier for you people. I hope it will make sense. The starting compound for the synthesis of the ketamine hydrochloride is benzene, chlorine and CN. So collectively it is known as 2-chlorobenzonitrile. This is the starting compound, and always the starting compound for synthesis is necessary in order to memorize what reaction is going on. The second starting compound or the product which has to be undergone the reaction is cyclopentyl magnesium bromide. So it is a cyclopentane along with the magnesium and bromide. So these two residues or the compounds undergoes another reaction with the removal of HBr. So they will form the same compound as we have chlorine, but instead of the nitrogen we are now having carbonyl oxygen with the presence of the water, which comes from the hydration, and remaining residue is the same along with cyclopentyl. So now this compound is the other derivative of the ketamine synthesis, which is known as orthochloro or 2-chlorophenyl, because we are having 5 carbon atom, 6 carbon atom, cyclopentyl ketone because of the carbonyl oxygen. Okay, I hope this makes sense and make it easy for you people. Now this orthochlorophenyl cyclopentyl ketone undergoes bromination reaction. So just memorize it. Remember that all the chlorine atom, all the parent compound is the same, just there is addition of one bromine, and remaining derivative or the compound is still same. So I hope this makes sense. And now what is known as, so it is the derivative of orthochlorophenyl cyclopentyl ketone, but because of the bromine we termed as the derivative as bromoketone. Then this bromoketone undergoes reaction with the methylamine. CH3NH2 is a methylamine with the removal of HBr. So how this reaction takes place? So here is a representation. We are having benzene, chlorine, which is the same, and we are having this CH3 instead of now carbonyl oxygen. We are attaching nitrogen with CH3, and remaining compound is the same, cyclopentyl, and HBr is removed. So instead of this bromine, I have mentioned this incorrectly. This bromine is replaced with OH. I will try to make another video on this. So remember that this BH is not this Br is not here, it is actually OH. So then we are having heat and addition of the hydrogen. So finally we are going to add one more carbon or cyclization reaction, that is the parent compound is the same. Instead of the OH we are having carbonyl carbon and NCH3, which is the same. So this is all about the synthesis of ketamine. I hope this makes sense. Only the issue is with the BR. I will tell you how to manage with it. Then we have properties of the ketamine hydrochloride. It is white crystalline in nature, white crystalline powder, which is freely soluble in the water, which is freely soluble in methanol, which is freely soluble in ethanol. So these are the main component in which ketamine hydrochloride or ketamine is freely soluble, that is water, methanol and ethanol. Okay. Then we have a mechanism of action. In pharmacology I am only discussing here mechanism of action because it is important to memorize it. As discussed earlier, ketamine hydrochloride interacts with NMDA receptor, or ketamine interacts with NMDA receptor. So what is NMDA? NMDA is N-methyl D-aspartate. N-methyl D-aspartate, that is a receptor family. This NMDA receptor, if we discuss about the details of the NMDA receptor, it is an inotropic glutamate receptor. Inotropic glutamate receptor. Okay, what does this inotropic means? Inotropics are ion gated channels. These are ligand gated ion channels which causes depolarization of certain neurons, so causes excitation. So when it is activated, ion channels or activates by the neurotransmitter which is known as glutamate or glutamic acid. So glutamate, you might have heard that glutamate or glutamic acid is excitatory neurotransmitter. Okay, so this is the normal process, that NMDA receptor is inotropic, which is a glutamate receptor, that in turn is ligand gated ion channel activated by glutamate, which is an excitatory neurotransmitter. So when ketamine is given or injected, so it interacts with NMDA receptor, particularly with inotropic glutamate receptor, and blocks a ligand gated ion channel and suppress or stops ultimate excitation of the neurotransmission of the glutamate or the glutamic acid, as glutamic acid or glutamate is excitatory neurotransmitter. So net result is suppression of excitation or suppression of the excitatory neurotransmitter. I hope this makes sense. But important point which is important to mention here is that it has nothing to do with the GABA. So there is a confusion that it is an inhibitory neurotransmitter, so it might act with the GABA, but it has nothing to do with the GABA. So the last, which is the important parameter of the structure of ketamine, that is structure activity relationship, that is SAR, which is an important parameter to discuss in the medicinal chemistry. So SAR, in this SAR, ketamine has two forms, or what we can say, two enantiomers. Two isomers are there, which is commonly known as stereoisomers. One is known as S-ketamine and second is known as R-ketamine. So I hope you people have clear understanding about stereoisomerism. We are having two forms, that is, one is S-ketamine, second is R-ketamine. Both have the different properties. So when we are having this isomers, stereomers, it is responsible for, S-ketamine is responsible for its anesthetic activity. It is responsible for its anesthetic activity. And R-ketamine is the different one. And R-ketamine is responsible for hallucinogenic effect. I hope this makes sense for you people, and try to make it simple and clear.